Hi guys, welcome back to my channel. Before we start with our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more math videos. So for today, we're going to talk about the distance formula. The learning competency about distance formula is that it applies the distance formula to prove some geometric properties. We're not just simply going to solve for the distance between 2 points. Rather, we're going to use the idea of distance formula to solve some or to prove some geometric properties. So as a beginning activity, let's have this. So I know you are already familiar with this one because it was taught when you are still in grade 7. So this is actually the way of counting the number of units from point A to point B. So we're talking about the absolute value of the number of units. Now, use the number line below to find the length of each of the following segments and then answer the questions below. So as you can see, we have our number line and the points. Let's have number 1, segment AB. So to know if what is the distance between A and B or points A and B, you have to count the number of units from point A. So it's 1, 2, 3, 4. So from point A to point B, we have 4 units. Simple as that. Let's have number 2, segment BC. So from point B, you will count the units going to C. 1, 2, 3, 4. Okay, so the answer here is 4 units as well. Okay, can you follow? And then for number 3, segment CD. So from point C, you will count 1, 2, 3, 4, 5, 6. So we have 6 units. So the distance between point C and point D is 6 units. And then let's have number 4, segment DE. So for segment DE, let's count 1, 2. We have 2 units. And then for number 5, we have segment EF, 1, 2, 3. So we have 3 units for segment EF. And then lastly, number 6, segment FG is 1. Okay, so 1 unit. So that's how you actually get the distance between 2 points using a number line. Just count the units from the first point up to the second point to know the distance. Next, the distance formula. Okay, the distance D, symbolizes by D, between any 2 points with the coordinates x sub 1, y sub 1 for the first point, and x sub 2, y sub 2 for the second point is given by, so just remember that to locate the point in a Cartesian coordinate plane, you have to have your coordinates, your x and your y values. Now, the formula is substitute the coordinates of the first point and the coordinates of the second point. So, distance is equal to square root of quantity x sub 2 minus x sub 1 square plus quantity y sub 2 minus y sub 1 square. So, if this is the Cartesian plane and we have 2 points A and B, so point A contains the coordinates of x sub 1 and y sub 1. That's the exact location. Then point B, we have x sub 2, y sub 2. So, to solve for this distance, you will have to use this formula. Okay? Next, let's have the first example. Find the distance between point P, 4, 3, that's how you read it, and point Q, 9, 15. So, let's solve for this one. So, the first thing is, for you to be able to easily solve for this, please make sure to label your events. So, your 4 is your x sub 1, your 3 is your y sub 1, your 9 is what we call your x sub 2, and then 15 is your y sub 2. Then the next thing also, we need the formula D is equal to square root of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Okay, so this is our guide in solving. Then the next thing is, let's solve. We are solving for segment PQ. So for segment PQ, just substitute the values. So x sub 2 is 9 minus 4, which is x sub 1 square plus y sub 2, which is 15 minus your y sub 1, which is 3 square. Then the next thing is simplify. You have to simplify from the expressions inside the parentheses first. So 9 minus 4 is 5 square plus 15 minus 3 is 12 square. And then the next thing is we are nearing the answer. So 5 squared is 25, and then 12 squared is 144. Okay? Then 25 plus 144 is 169. Then extract the square root, square root of 169. Since 169 is perfect square, so the answer here is 13 units. So the distance between point P and point Q is 13 units. So segment P. Then, how about if you are going to substitute directly to your calculators? So let's please follow this instruction. So square root symbol, then open parenthesis again, then your x sub 2 is 9, and your x sub 1 is 4. Okay, square. Okay, how are you going to write square? So it's either on your old model calculators, you will be seeing this and then put 2. Or how in the other calculators, higher models, you will see this. Okay, so that's how you do it. Plus, your y sub 2 is 15, and then minus your y sub 1, which is 3 square as well. Okay, then hit equal sign. So you have to get 13 units. If not, you are incorrect. So it means there's something wrong with the values that you and symbols that you have inputted on your calculators. Now, if in case you're not able to use your calculator, you by solving directly the distance, okay, you can just use your calculator as a guide in solving some minimum math concepts within the steps in solving. Okay, next example 2. Find the distance between each pair of points. So we have two pairs of points. So first is we have point A2 negative 7 and point B3 negative 2. So we will be solving here is point segment AB, and then in the other pair we will be solving segment CD. So the first thing is we have to label. This is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2. This is x sub 1, y sub 1, okay, x sub 2, y sub 2. Then the next thing is we have to write the distance formula. Okay, so this will serve as your guide in solving. Okay, then let's have segment AB. So for segment AB, substitute the values. Your x sub 2 is 3 minus 2, which is your x sub 1 square, plus your y sub 2 is negative 2. Okay. Then, by the way, this is negative 7. How are you going to write? Negative times negative 7. But if you're going to multiply them, it will become positive. So you can just simply write plus 7 here. Square. Okay? That is to simplify the process. If they are both negative and you're multiplying them, the sign of the answer is positive. That's why we will put positive 7. That's if the second value, or your x sub 1 or your y sub 1, is either of the two is negative. Now, let's proceed. So 3 minus 2 is, for those who are watching, you can try using your calculators by substituting directly. So 3 minus 2 is 1 square, and then plus negative 2 plus 7 is 5 square. Then extract the root, 1 plus 25. So 5 square is 25. Then 1 plus 25 is 26. So the square root of 26 is the answer. Now, we cannot anymore factor 26 wherein we will get 1 of perfect square. So to simplify, so this is already simplified units. So, but if you are using your calculators, the square root of 26 is approximately 5.099 or 5.1. Okay. So, but it depends on your examination if your teacher is going to require radical expression or whole number or the decimal. Okay, so it's your teacher. Now, let's proceed to the second one. So let's substitute. We are solving for segment CD. Okay, so your x sub 2 is 4 minus 2 squared plus 5 minus or plus 1. Why plus 1? Because as you can see, this is negative. Minus times negative is positive. Okay, so put the square root symbol, don't forget. Then 4 minus 2 is 2 square, plus 5 plus 1 is 6 square. Okay, then the next thing is 2 square is 4 plus 36. Okay, so 4 plus 36 is square root of 40. Now, as you can see, 40 can be factored, okay? So, 40 is also not a perfect square. That's why we can extract the square root of this. So, what are the perfect square numbers? We have 1, 4, 9, okay, what else? 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and so on and so forth. Now, we have to factor 40 wherein we will get 1 perfect square. So, what are the factors of 40? We can try 4 and 10. So, since 4 is a perfect square, so a square root of 4 is 2 square root of 10. So, 10 is not a perfect square. That's perfect square. That's why it will remain inside the radical symbol. So, the answer here is 2 square root of 10 units. So, for those who are using your calculators, you can just type in 2 square root of 10. So, the value of this is 6.32. So, to change the value from radical to decimal, decimal to radical on your calculators, after you hit the equal symbol, so you can just hit the SD symbol, okay? And then it will change your answer for the higher model of calculator. Now, let's proceed. Okay, if you have questions and clarifications, most especially to my students, you can directly contact or message me. Okay, it's in my contact information. Alright, so let's have number 3. So examples 1 and 2, that's those examples are just about solving for the distance between 2 points using the distance formula. So we will now have the learning competency. We will prove some geometric properties using the distance formula. Let's have number 3. The vertices of triangle HOT are point H45, point O11, and point T5, negative 2. Show that triangle HOT is isosceles. Okay, so that's it. By the way, before we go ahead, when we say isosceles, we'll start first with equilateral triangle. So classifications of triangles according to sides. So when we say equilateral triangle, all sides are equal. When we say isosceles triangle, guys, so 2 of the sides are equal. So only 2 of the sides are equal. But when we say Scalene triangle, no sides are equal. So that's the difference between the different classification of triangles according to sides. Lateral sides. Now, so we are going to prove if HOT is isosceles. For us to say that, we have to have at least 2 sides that are congruent. So if we're going to draw the triangle here, HOT, okay, so we need to solve for segment HO, segment HT, and segment OT for us to find out if this is isosceles triangle. That's by using the distance formula. So we will now prove if triangle HOT is isosceles using the distance formula. So the first thing is we will be solving for HO. Okay, so we will be solving for HT as well, the other side. And lastly, we will also be solving for OT. Okay, so these are the points that we are using for HO. Okay, we will use point H, 4, 5, and then O, 1, 1. This is O. Okay, and then for HT, we will be using 4, 5, and then we will be using 5, negative 2. Okay, and then for OT, we will be using 1, 1 for O, and then for T, we have 5, negative 2. Right, so we can now proceed. Okay, so the distance formula is equal to square root of x sub 2 minus x sub 1 square plus y sub 1 minus y sub 2 square. So this is now the formula that we're going to use. Now, for HO, your x sub 2 is 1 minus for your h sub 1 square plus your y sub 2 is 1 minus 5 square. Okay, and then the next thing is 1 minus 4 is negative 3 square plus 1 minus 5 is negative 4 square. Then, negative 3 square is 9 plus 4, negative 4 square is 16. Okay, add them up. Okay, so 9 plus 16 is 25, and square root of 25 is 5 units. So, one of the sides measures 5 units. Then, the next thing is we have 4 HT. So, segment HT, your x sub 2 is 5 minus your x sub 1, which is 4 square plus negative 2 minus 5 square. So, don't forget to put the square symbol. 5 minus 4 is 1 square, and then negative 2 minus 5 is negative 7 square. Then 1 square is 1 plus 49. 7 times 7 is 49. Okay, so 1 plus 49 is square root of 50. Then this is not the perfect square, so we can factor. 1 must be a perfect square, so we have 25 and 2. So square root of 25 is 5, and then copy 2 inside the radical symbol. So the answer is 5 square root of 2 units. Now, for it to become isosceles, we have to have at least 2 sides that are congruent. So let's proceed to OT. it must be 5 or 5 square root of 2. Okay, so if not, it's not an isosceles triangle. Okay, so your x of 2 is 5 minus 1, your x of 1, plus negative 2 minus 1. Then the next thing is 5 minus 1 is 4 square, plus negative 2 times minus 1 is negative 3 square. Okay, let us simplify. 4 square is 16. Okay, and then negative 3 times negative 3 is 9. Okay, so 16 plus 9 is 25, and square root of 25 is equal to 5 units. Do we have two sides that are congruent? Yes, 5 units and 5 units. Okay, then let's also graph it. So for point H, to graph it, we have 4 and 5. So 4 and then going up 5. So this is H. And then we also have 1, 1 for O. 1, 1. So that's how you actually interpret it. And then we have 5, negative 2. 5 going down, negative 2. This is T and this is O. Then draw the triangle. Okay, so this is 5, and this is 5 square root of 2. So therefore, we can say that triangle isocot is an isosceles triangle. Okay, that's it. So triangle HOT is an isosceles triangle. We are able to prove that triangle HOT is an isosceles triangle because of the distance formula. Okay. Next. Example 4. Another example. Show that triangle SIM is a right triangle. For point S is 4, 5, point I is 1, 1, and then point M is 0, 3. Okay. So same thing, we're going to draw the sketch of the triangle. So we have SIM. We will be solving for SI, segment SI, segment SM, and segment IM. Then write the points. Okay, for SI we have 4, 5. We have 1, 1. For SM we have 4, 5, and 0, 3. Then for IM we have 1, 1. Then we also have 0. Let's start. Okay, so for the first one, okay, your x sub 2 is 1 minus 4 square, and then your y sub 2 is 1 minus 5 square. Then let us simplify. Okay, by the way, when we say right triangle, one of the angles is a right angle or measures 90 degrees. Okay, so we will be solving first for the sides, and then afterwards we will be using Pythagorean theorem to prove if this is a right triangle. So 1 minus 4 is negative 3 square, plus 1 minus 5 is negative 4 square. Okay, so negative 3 square is 9, then 16, 4 times 4. Add them up, you will be getting the square root of 25 or 5 units. So segment SI measures 5 units. Okay, let's have segment SM. Okay, so your x of 2 is 0 minus 4 square plus 3 minus 5 square. Okay, that's it. Then 0 minus 4 is negative 4 square. And then 3 minus 5 is negative 2 square. Then after that, okay, so this negative 4 square is 16. Negative 2 square is 4. Add, and then 16 plus 4 is 20. Okay, get one factor which is a perfect square, that is 4 times 520. So square root of 4 is 2 square root of 5 units. Then let's solve the last one, segment IM. So for segment IM, okay, so your S sub 2 is 0 minus 1 square plus 3 minus 1 square. Okay, so 0 minus 1 is negative 1 square, and then 3 minus 1 is 2 square. Okay, negative 1 square is 1, and then this is 4. So the answer here is square root of 5, and you cannot anymore simplify that. Okay, so segment SI measures 5 units, and then segment SM measures 2 square root of 5 units, and IM measures square root of 5 units. Now, how are we going to prove if this is a right triangle? So we will now be using the Pythagorean theorem. So just remember that Pythagorean theorem is a theorem only for right triangles. Okay, So the general formula or equation is c squared equals a squared plus b squared. Take note that c is your hypotenuse. So if this is your right triangle, this is your hypotenuse or the longest side, okay, either of the legs AB. Okay, so c is your hypotenuse. So look for the highest value, okay, which is the highest value. So 5, 2 square root of 5 or square root of 5. So 2 square root of 5 is approximately 4 point something. It's not the highest. Okay, so it's 4.47. Then square root of 5 is approximately 2.187. So it means that 5 is the highest, so therefore 5 is your hypotenuse. So we will be using the radicals, okay, in solving or in substituting. So your C will be square root of 25 square, while your A, you can have it as square root of 20 square, and then your B will be square root of 5. And then, okay, use your calculator to simplify, but if you're going to extract the square root with the square, okay, so it goes like this. You will cancel the radical symbol with 2. So what will remain, we have 25, 20, and 5. So they must be equal, so 25 is equal to 20 plus 5, 25. So therefore, okay, it satisfies the equation of Pythagorean theorem. We can say that triangle SIM is a right triangle. Is a right triangle. So that's it. So those are just some of the examples of proving some geometric properties using the distance formula. So there's a lot of it. Okay, so just take note of the things that we have learned for today. So for my students, please answer this. Okay, you know where you should do it. Okay, and then to those who are watching and learning from this channel, thank you so much. Please don't forget to hit the subscribe button and the notification bell for more videos. So this is Teacher Dong, and have a nice day.